Hey guys, welcome back to my YouTube channel. My previous video we discussed on a question whereby you have for what values of key or values of key we have a quadratic equation. We have a for a quadratic equation whereby we have two distinct roots, two equal roots, or two imaginary roots. In our previous video we did the same example for each scenario. For this video we're going to be doing different examples so I'll have more knowledge on how to tackle any questions that come our way. I mean, straightforward. I've already told you before, both distinct real root and two real roots, they give you a range of values where key can be, while real equal root gives you a certain number or at most two numbers whereby they can be real roots. So let's dive into it. Whereby when we have two distinct roots, remember when that means d has to be greater than 0, right? So when d is greater than 0 and we know d to be b square minus 4ac 0, and what's our b? We have b to be, okay, let's say b is k is 2 and c is minus 3, right? So we have k square minus 4a is 3 minus 0, k square minus we have 8, we have 24. You notice this, either you take it this way, let me just take it this way. Either you take it this way. Okay, so this should be a plus because of a plus, yeah. So if you leave it this way, any number you add, you square or more, you add to greater than 0, or take it further, you have greater than minus 24. Because any squared number, as long as it's in the range from minus infinity as this to infinity, will obviously be greater than minus 4. Because if you square any negative number, you have a square. So k here to be all real numbers. So we have this in an object question now. This will be the answer. All real numbers. All possible number decimal. If the decimal minus 2.4, if squared is still greater than this, or you have even minus 2, we still have something greater than this. So either way, all real numbers will fit into the value of k here. So any real number can be k here, and I will give you two distinct number. Then coming here, there has to be equals to 0. I have b squared for is equals to 0. About is 1, b equals to minus 4k, please take notice together. Then plus c equals to plus 9. So you have b as minus 4k all squared minus 4 is 1, b is c is 9 equals to 0. Since it's equals to, but dealing with equals to 0, so we have this one to be 16k square. Then if you multiply this, you have minus 36 equals to 0. So take this to the other side, I have 16k squared. Divide both side by 16, everything 16. If we divide 4 in both sides, I have 9 over 4. And if you take the root of these both sides, you have 3. Note this plus or minus here, so you have plus or minus 2. So for this particular equation, k has to be either minus 3 or plus 3 over 2. So in substituting it back, you have to multiply it with the 4 to get the value of x. Multiply it with minus 4 to get the value of x. Then for the last example, you have d less than 0, we have b squared minus 4 is equals to 0, is equals to 1, b is equals to 5, c is equals to k. I think with this first one solve something like this. Then we have b substitute b squared is 5 square minus 4 a and 6k greater than less than 0. So you have 25, that you have 4k less than 0. So you take this one to the right side and minus 4k. Okay, you can divide both sides by minus 4. When I'm dividing true by a negative, what we have a sign here, especially inequality, you change it the other way around. So you have minus 25 over 4, right? Thank you very much.